we can use the grid command to create a lattice, a very intuitive name. We do this in line 8, defining the drawing now not of a line, but of a grid which goes from the lower left corner to the upper right point. It became even simpler, only 3 lines. However, I am very picky, and you may notice that there is a burr left on the outer vertices of the grid. This is due to the thickness of the line. The solution is to return to the first method and stretch the line by a factor alpha, which is equal to half the line. In other words, the line thickness increases around the points that define it. So if the thickness causes this difference, simply stretch it by half that length on the far left and far right of the grid. To do this automatically in the main file, we define the thickness on line 20. We must write it without units so that it is possible to perform calculations with this variable. However, by default the line thickness is defined in units of pt, while the line length is in cm. So on line 21, I create a conversion factor from pt to cm. Finally, on line 22, I define the variable burr, which takes half the line thickness and converts this value from pt to cm. Returning to the drawing. To check if this is correct, in the drawing document, on line 22 we define a horizontal line, and on line 23 we create a perpendicular line where we add the correction factor above and below, and as we saw, it worked. We can also do an extra check and define the lowest point without the correction factor, and notice that now it starts at half the thickness of the horizontal line. Now we apply this correction to our lattice on lines 29 and 30, where we use the loop again. A perfect grid! This implementation is of no use for the spin lattice, but if you really want to make a grid without adding circles at the vertices, here is the solution.